Lesson 8.3, Unit Analysis 3, Weight, page 589. This is a really short chapter or section, and the reason for that is we've already learned how all this works. So we're just trying something different, dealing with weight now instead of length or area. So let's just look at number 1. And notice there on page 589 there's two sets of tables. The top one has to do with units of weight in the U.S. system. The bottom one deals with metric units of weight. So example 1, we're going to deal with the U.S. system, and we've got 12 pounds. I'm going to label pounds LBS. That's the abbreviation for pounds. We're going to change those pounds to ounces, and ounces is labeled OZ. Don't ask me why either one of those are labeled the way they are, but welcome to America. That's just the way they go with that. So we're going to change pounds to ounces. So we're going to do our 12 pounds, no exponent up here, so one X and one line. Our pounds is going to go on the bottom. And do we know anything about pounds and ounces? Well, if we look at that top table there in the middle column, it says 1 pound equals 16 ounces. Okay, so that's the only thing there as far as pounds and ounces. Well, we put that over 1, cancel our pounds, multiply 12 times 16, and we get 192 ounces. So, not too bad. Let's look at example 2. In example 2, they're converting tons to pounds. You'll notice that the abbreviation for tons is the capital letter T, and we're converting 3 of those tons to pounds. So 3 tons times line, tons on the bottom. We look at our table, see if there's any comparison, and we find that there are 2,000 pounds in 1 ton. Cancel our T's here for our tons, multiply 3 times 2,000, and we get 6,000 pounds. When we deal with the metric system, again, we're just dealing with numbers with multiples of 10, so that makes it a little convenient. We're going to convert 3 kilograms. There, kg is the abbreviation to kilograms, and we're going to change that to centigrams. So let's write our 3 kilograms times line. Again, no exponent there. And we look on our table, bottom of page 589, and we find out that there are 1,000 grams to 1 kilogram. And we do that because I'm not seeing any kilograms to centigrams. So we're going to have to slowly get to centigrams, because the only time centigrams appears is when it goes from 1 gram to 100 centigrams. So because kilograms does not go to centigrams, but grams does, we're going to have to convert to grams so that we can convert to centigrams. So a little confusing, but you gotta go with what they give you in the table. So you gotta convert in the direction that they're telling you to convert. So I can cancel these because I got a kilogram here and a kilogram here. The gram here, that's not what we're looking for, so we put a gram down there. And do we know anything about centigrams? Yes, we know that there are 100 of them in 1 gram. So we can cancel our grams here, put that over 1, multiply our numerators, and divide by just 1. So we got 3 times 1,000 times 100, which gives me 300,000 centigrams. I put meters up here, sorry about that. It should be centigrams. Alright, so if you look at example 4, they give you a story problem having to do with medicine. Don't let this story problem fool you. All the ones in the homework are similar. Got a bottle of vitamin C, and it's got 50 tablets in it. So let's put 50 tabs up here. And each tablet contains 250 milligrams. What is the total number of grams in the bottle? So what they're asking you to do is how many grams are in all 50 of these tablets added up. Well, first of all, we need to find out how many milligrams, because that's what they give us here. This is weight. How many milligrams are there in 50 tablets? Well, there's 250 per 1 tablet, So 2 would be 250 plus 250, or 250 times 2, so it would be 502 tablets. So what that's saying is, if we know that 250 is in one tablet, in 50 tablets it would be 250 times 50 tablets. And that would give us the total weight of that bottle of vitamin C in milligrams. So 12,500 milligrams is the total weight of 50 tablets. But they're not asking for the total weight of the 50 tablets in milligrams. They're asking for the total weight in grams. So we have to change milligrams to grams. So let's get rid of this since we're done with that. Times line. Alright, if we go back, we can, let's see, we know that there are 1,000 milligrams to 1 gram. If you look at the table on page 589, middle column, very first one. Oops, got this backwards. Notice I've got grams down here that doesn't jive with this one, so I got them upside down, so I need to flip them. 1 gram over 1,000 milligrams. Now I can cancel my units. I'm left with grams. Put that over 1. Multiply 12,500 times 1. Don't worry about that. Divided by 1,000. And I end up with a bottle that weighs 12.5 grams, because that's what I have left is grams. I didn't cross those out. So that is the lecture for problem set 8.3. Let's look at some of the problems. So if you look at page 591, 1 to 30, we're just converting weight to weight and just going from in 1 to 15 the US system, 16 to 30 the metric system. Let's look at something like a number 12. We've got pounds and we're going to ounces. So we've got 5 1/4 pounds times line pounds. Do we know anything about pounds and ounces? Well, if you look back at your table, you'll find out that 16 ounces is 1 pound. We can cross out our pounds. So what we're going to do is we're going to multiply 5 1/4 times 16. Or if you get your handy dandy calculator out, it's 5.25 times 16. And that gives me 84 ounces there. So, some real basic multiplication is all you're doing, and you end up getting your 84 ounces. You do the same thing on 16 to 30. You just translate it using the table on page 589, just like you use the US table. If you turn over to page 592, there are some story problems, 31 to 38. They're all done just like the one we did prior to this with the 250 milligram bottle of vitamin C, 250 milligram per tablet, and there were 50 tablets. So we multiplied the number of tablets times the weight of one to get the weight of the entire bottle, and then we translated it or converted it to whatever they were asking for. So if you could do a problem like example number 4 on page 590, you won't have any problem with 31 to 38 on page 592. So that's 8.3.